Let's see. I want to record this. Okay, thank you for coming to today's class. What we want to try to dive a little bit deeper in what is the case 3.1 when the graphing rational expression about. The first thing that we have to notice and to make sure, guys, is to identify why it's this. If we had a function y, I was sure that this is the case 3. And it's simple. It's just not this, guys, and identify the degree of the numerator is greater for 1 unit the degree of the denominator. What is that? For example, if you're gonna have something in the numerator like x squared, that's the highest degree, and the denominator is gonna be x to the first power. Okay, that's gonna be. Okay, what are we gonna do, guys, in the case 3.1? Okay, the first thing, guys, that we try to do when graphing any rational function, regardless the case, is to find a horizontal and vertical asymptote. That's the first key. That's the most important thing when graphing it. And I'm gonna ask you something. The vertical asymptote here I got. How can I find it out? Okay, I need to set the denominator equals to 0 and solve. Surely. Okay, notice that the vertical asymptote never changes. Okay, it doesn't matter that you're working with a case 1, 2, or 3, or 3.1 or 2. That denominator, guys, you set the denominator equals to 0 in order to find a vertical asymptote. Okay, this is exactly the same. What is going to change? The horizontal asymptote. And notice that the case 3.1 is a little bit different because the horizontal asymptote, guys, is not going to exist anymore. We're not gonna have a horizontal asymptote at all. Okay, instead, okay, if we don't have horizontal asymptote, what are we gonna have then?
An oblique
Therefore, there will be an oblique slant asymptote. And what is an oblique in slant asymptote? Okay, let me give you an idea before going to the graph. And an oblique asymptote, guys, is just a line that is neither horizontal nor vertical. It's something like this. Okay, it's a line with a slope. It's a line with an inclination. It could be something like this. It could be something like this too. Okay, but it's never going to be a completely straight horizontal asymptote. That's the difference, guys, in the case 3.1, and this is why this is a little bit different than the other ones, but it's nothing difficult. Sorry about that. Repeat: horizontal asymptote is an slant or oblique asymptote, and the vertical asymptote is exactly the same. You set the denominator equals 0 and you solve. Okay, I've talked a lot, so this is why I just want to focus myself in this, and we're gonna try to graph this. Okay, please, let's copy this in. We're gonna work out. Okay, we got this, guys. We need to tackle this down aggressively. The first thing that we're going to do is to identify which case this is. Of course, we know the case, guys, but I want you to tell me which case it is.
3.
Case 3, and explain me why. Okay, you're right. Case 3.1. Okay.
because of the unit of
3.1 because the numerator is greater than the denominator.
For how many units this numerator is greater than this?
1 unit.
1.
For 1 unit. Okay, this is a square and this is 1. The difference between them is just 1. 2 minus 1 is 1. Excellent. Okay, that's why we call this case 3.1. Thank you. That was helpful, guys. Amazing. Okay, now let's try to find a horizontal. Okay, we don't have horizontal asymptote. Let's start off with the vertical asymptote. Okay, I'm gonna start off with the vertical asymptote. Okay, what I want to try to do is to find out the vertical asymptote. I'm going to start off with that. Okay, vertical asymptote. And how do I find a vertical asymptote, guys? Help me.
Denominator equals to 0.
That denominator equals to 0. Guys, case 1, case 2, case 3 is going to be the same. Even if we have the case 4 or 5, which we don't have, but it's the same. X minus 1 equals 0. And you need to solve for x, guys.
X equals positive 1.
X equals positive 1. Thank you very much. This is my first important information, vertical asymptote, which is x equals to 1. Okay, let's go to the horizontal asymptote. Do we have?
We don't have it.
We don't have. We don't have any horizontal asymptote anymore. Instead, what do we have?
Oblique or slant asymptote.
Excellent, excellent. Okay, oblique or horizontal, oblique asymptote. Okay, oblique asymptote. Okay, notice something, guys. Mister, how do I find the oblique or horizontal asymptote? Can someone tell me how do I find that out, guys?
Using long division with the
Using
function.
long division. Excellent. Dividing this numerator over this by the long division. Mister, but what if I want to factor? Okay, that's a good question. Okay. Try to factor this and tell me if you can simplify this, guys.
It's possible. You can cancel x minus 1 and it's
Can I
gonna be only
cancel?
x plus 1.
You sure? Okay, I'm gonna stop the video because I don't want to make it that long. Okay, we try to factor and simplify this, and we realize that that is completely impossible. Okay, what do we have to do? Find a horizontal oblique asymptote. Okay, and how do we do that? Pretty simple. By, Sarah told me, by dividing x squared minus x plus 1 all over x minus 1 using the long division. Okay, we're gonna focus ourselves in this, and we're gonna divide that. Okay, let's start. The first thing, guys, when dividing using the long division is to take the highest degree and find the ratio of it. Okay, what is that? Okay, I'm going to divide this x squared over this.
X,
X squared over x. What is that equals to?
x,
X to the first power, right? X squared minus 1 or just 1x. Okay, I'm going to put that as my quotient. Okay, x. Okay. And now it's like the dividing numbers. This multiplying this divisor, multiplying quotient. Okay, x times x, guys.
x squared
X squared, thank you.
minus
X minus 1
minus x.
minus x. Okay, this is what I got. But do you remember that we need to use a negative because we subtract, we take this away. But instead of using a double negative, what I taught you guys to do kind of a trick is
To
just
change the signs.
excellent. Because of the negative, right? This is positive. It's going to turn into negative. This is negative. It's going to turn into positive.
Positive.
Okay, this is the idea, guys. I know that it looks a little bit informal, but it helps. X squared minus x squared. Let's find this out. 0,
You can
right?
cancel
Okay, this, guys, minus x plus x.
0.
Okay.
0
Oh my gosh, that is 0. It's even better, guys. Okay, let's get down the next number.
plus 1.
Plus 1. Okay, but guys, in this case, I don't have variable anymore. Do you remember that? Maybe you have forgotten this step. But when you get number here, you have finished it. Okay, you don't need to, you don't need to continue because if you divide this, take a look, 1 over x, you're gonna get 1 over x again. Okay, there is nothing that you can simplify, guys. Okay, this is the remainder, actually. This is the remainder. We don't need it, guys. Okay, what we need is, guys,
Quotient.
the quotient, which is, okay, this is what we need. Okay,
X.
guys, that is going to be my oblique asymptote. Okay, let's copy that. It's going to be y equals to what? The quotient, which is,
X.
thank you, thank you, thank you, thank you. Okay, this is my oblique asymptote. Okay, I know that I have talked a lot, guys, but as you notice, it is not that difficult. Again, the vertical asymptote, you only said that denominators equals 0 and solve. Is the same, never has changed. Oblique asymptote, guys, is, since that this is a prime trinomial, you cannot simplify, okay, you cannot factor it, you use long division. Okay, this divided by this, and what you got, guys, as a quotient, that is going to be your oblique asymptote. It's going to be a linear function. Okay, now, guys, let's represent this oblique in vertical asymptote. Okay, let's do that. Okay, let me see. The first, what is the vertical asymptote, guys? Okay, we know that is x equals to
X1.
x1. Okay, I'm gonna plug that first. Okay, before going into the graph per se, I need to find information out of this, right? This is a linear function, and how do we graph the linear function? Instead of using a table that takes a lot of time, guys, we're gonna use this using the slope-intercept form, right? You remember, you need to identify a slope and y.
The
Thank you,
Y.
Sarah. Y-intercept. Okay, what is the slope in this function? What is the coefficient in x?
1.
1, but I need a fraction, Sarah.
Over 1.
Okay, thank you. That's it. And what about the y-intercept? What is the number that is here?
0.
0.
Thank you, all of you. Thank you, all of you. I'm going to remind you guys that this is y, the change is y, and this is the change in x, right? The slope,
X.
change y over change in x. Thank you. With this information, guys, is good enough to make our vertical and oblique asymptote. Okay, let's try to do that. The vertical asymptote is x equals to 1. Vertical, x0, x1. Okay, let's make it here, guys. X. Okay, this is x equals to 1. That's it. Okay, the my oblique asymptote is this, guys, this function y equals to x. Okay, with this information I can graph it. First of all, the y-intercept. Okay, what is the y-intercept in this function?
0.
Okay, where
0.
does the graph crosses in x equals to 0? Okay, in this
In the
point,
origin.
in the okay, excellent, excellent. In the origin. And what about the slope? I need to move according to that slope. Okay, this is my first point. How many
1 for
units
X.
in y? 1. Okay, let's move 1 units in y. And how many
1.
units in x?
1.
Okay, okay, just this. 1 unit is up, 1 unit is to the right. Okay, and here's gonna be my second point. And now let's make the line. Okay, I'm gonna make that line. Let me try to do my best, guys. I'm not so good at this. I'm telling you with time, but I'm gonna try to. Oh, amazing. This is the best graph that I've ever gotten. Okay, now I'm going to dash this line. Okay, I'm gonna dash this line because it's a asymptote, which is just dash. The graph is going to approach to this point, but it's never quite gonna touch it. Okay, take a look, guys. With this, guys, with this information, we are good enough capable of making a table. And what we're gonna do again, this is the same, guys. You focus yourself in the vertical asymptote. Okay, how many values? You're gonna take values to the right and left of this
2 to the
vertical
left
asymptote.
and 2 to the
Okay,
right.
thank you, thank you, thank you. Okay, let's zoom in here. I'm gonna try to make a table, a decent table, guys, because I'm really bad at doing this. Okay, this, and this. Okay. Okay, we have x and we have y. What is my function? Can someone remind me what my function is?
X squared minus X.
Minus x,
I think that plus 1.
all over
Over
x minus
X minus 1.
Minus 1.
okay, I remind me that. Okay, this is, guys. Okay, now these values we're gonna use in the table. Okay, vertical asymptote. We don't include it. This is just the center of my table. Values to the left of this x1, guys.
Negative 1 and 0.
Okay, what about C? Okay, 0 and negative 1. Negative, okay, you're giving me the order actually. Thank you. Negative 1 and 0. Thank you. Two values to the left. Now, values to the right of this point.
2 and 3.
2 and 3. Okay, let's take 2 and 3. And let's see what we're gonna get. Okay, let's zoom in, guys. And let's get right with calculators. I'm gonna need them. Okay, let's put parentheses. Okay, I'm going to zoom in parentheses, square minus parentheses plus 1 all over parentheses minus 1. What do we get if we substitute negative 1 here?
Negative 1.5.
Negative 1.5. Anyone got the same or different answer? Help us, just to check it out.
Negative 1.5.
Okay, we are okay with that. Okay, the other one, what about 0, guys? Oh my gosh, I love using 0, guys. I can tell you, it's negative 1.
Negative 1. Yes, negative 1.
You see how clever am I? Just kidding, guys. Okay, it's really simple because this is cancelled. This is just 0, 0, and you will only find this 1 over minus 1, which is minus 1. Okay, let's continue. What about this when we substitute 2?
3.
Okay, minus 1. We're going to substitute 2. Okay, 2 is x, and we got 3. Saratolos is 3. Please check it out, guys. Check it out. If you got it different, just tell us. Okay, we are here to help each other. Okay, now we substitute 3. What are we gonna get?
3.5.
3.5. Thank you. Okay, guys. With this information on our hands, We're completely capable of having this done shortly. Okay, let's try to do the first one. Negative 1 for x. Okay, let's look. Negative 1 for x. And how many for y?
And negative 1.5.
Thank you. Negative
Really
1.5,
close.
negative point and a half, right? Okay, it's a point, guys. Keep in mind this is a it's slant asymptote. It's never gonna touch it. It's gonna approach it, but it's never gonna touch it. Okay, negative 1.1 is going to be a point. Okay, let me zoom in because it's going to be something like this, right?
Close. Yes.
Okay, close to the middle between 1 and 2. And what is the next point? 0
0
with
0 and
minus
negative 1.
1.
okay,
Negative
0
1,
minus
sorry.
1. Thank you. 0 minus 1. Okay, which is exactly this, right? 0 minus 1. Okay, we got it. What about the points on the right? 2
2
with
2
and 3.
and 3.
okay, 2 and 3, guys, is gonna be this point, right? Okay, 2
Yes.
and 3, guys. It's gonna be I'm gonna use a different color for that part. 2 and 3. Okay, is this right? 2 and 3. And the other one?
3 and 3.5.
1, 2, 3 in x, and 3.5 in y. Okay, 3.5 is gonna be here.
Between 3 and 4.
Okay, between 3 and 4. Thank you. Okay, with this information, guys, on our hands, we are completely capable of doing it. Okay, keep on mind, I only have these 2 points here, but I know that this graph is going to what? Approach to,
The approaching. The
see, it's
asymptotes.
going to be approaching to the vertical and slant asymptote. That's the definition of it. Okay, this graph, guys, is going to be getting closer to this. Okay, I don't like it. So, okay, something like this. Okay, so like this is gonna be getting closer to this asymptote, but it's never gonna touch it. Okay, this is the first part. Let's go to this upper part and we're gonna do the same. Okay, this graph, guys, is going to be getting closer to this, getting closer to each of the vertical and oblique asymptote. Okay, and this is my graph. Questions so far, guys?
No.
Sure. Okay, and this is the top, guys, of a function. This is how we can graph, okay, a rational function using the long division. Take a look that I hope, guys, I really hope that this is clearer.